Hi, in this video we're going to continue to look at relative velocity. So let's get started. We've got a question here. You are walking with a velocity of 5 kilometers an hour due south. Your friend is running at 8 kilometers per hour due east. What is your velocity relative to your friend? So let's draw a diagram of this. We are moving south. Our friend is moving east. They are going 8 kilometers per hour. We are doing 5 kilometers per hour. We want to know what our velocity is relative to theirs. So if we show that as a vector, we're moving in this direction relative to them. So we're moving down and we're also moving away from them in the sort of west direction, if you can visualize that. So this is our resultant vector, this one, let's call it V. And we want to determine what V is, right? So if we call this A and B, we need to add these vectors. So we need to do the negative of A plus B. It's a plus. So we've got negative A is negative 8, 0, plus B, which is 0, negative 5, which gives us negative 8, negative 5. So that's our velocity relative to our friend, but we want to communicate it in speed and direction. Okay, so I'll go ahead and do that. Okay, so we found the magnitude, we got 9.43. The angle here is 32, but we want the true bearing, so we're doing 270 minus the angle, and we get 238 degrees true. So this is our velocity relative to our friend. Look at one more question. So here we have a plane is traveling with an airspeed of 600 kilometers per hour south. However, the plane's true velocity is only 570 kilometers per hour on this bearing. The reason why it's different is because there's a wind, and we need to determine the velocity of the wind. So again, let's draw a picture. We've got 600 kilometers per hour due south. The velocity is actually, the ground velocity is 570. So we'll draw those in. 600 kilometers per hour. This is 570 kilometers per hour. What are our angles? So this is, if we just work from here, 160 degrees is 90 plus 70, so it's 70 degrees. And that's going to be 270 degrees the whole way around, right? And we've got the wind. So if this is the 600 kilometers per hour is the airspeed, and this one over here is the true velocity, the wind must be blowing this way, right? To blow it towards that direction. Let's call this A, B, and C. So the true velocity, the ground velocity, is the sum of the other two, right? So we've got A plus B equals C. But we're trying to determine B. So vector B is just going to be vector C minus vector A. Can work that out. So vector C is 570 cos 360 minus 70, which should be 290, I think. Yep, 290. 570 sine 290 minus A, which is just 0, negative 600. Let's pop that in. Okay, so that's the velocity of our wind, but again, we need it in speed and direction, so I'll go ahead and do that. Okay, so we worked out the magnitude of our b vector, which is the speed of the wind, and we worked out the direction. So I drew a diagram here, worked out theta, then we worked out the true bearing, and we got 72 degrees true. Okay, so we again looked at relative velocity. This time we weren't just working out the velocity relative to the ground, but we were working back to find the wind velocity, or not the velocity of the object of the aeroplane relative to the ground, but something else. So we were just rearranging our equations to get what we wanted to find. So I hope you enjoyed the video. I'll see you for the next one. This video accompanies a worksheet series that aims to develop conceptual understanding with vectors. If you'd like to access the worksheet, click in the description below.